An AI accelerator does not only calculate, it converts electricity into heat at extraordinary density. The IEA-4E EDNA report says leading GPU thermal design power now exceeds 1,000 watts per chip, and that liquid cooling is becoming a prerequisite for high-density AI deployments. That creates a second market beside the processor. Someone must move heat from silicon to a cold plate, from the rack to a cooling distribution unit, from the building to the outside environment, and sometimes into a useful heat network. Nvidia may make the headline chip. The cooling money is distributed across an entire thermal supply chain. The report describes three main families. Direct-to-chip cooling mounts cold plates on hot components and circulates liquid through the server. Immersion cooling submerges equipment in dielectric fluid. Rear door heat exchangers capture hot exhaust at the rack. Direct-to-chip single-phase systems are currently the most mature and widely deployed, representing about 43% of liquid cooling market revenue in the report's assessment, while immersion is the fastest-growing segment. Each design changes who supplies the equipment, how facilities are built, and whether an existing server room can be retrofitted without a complete redesign. Follow the heat path and the supplier map appears. At the chip are thermal interfaces and cold plates. Inside the rack are manifolds, hoses, quick disconnects, sensors, pumps, and leak detection. Cooling distribution units manage flow and exchange heat with the facility loop. Outside the rack are pipes, heat exchangers, dry coolers, chillers, controls, and water treatment. Immersion adds tanks and specialized fluids. Every connection must perform reliably beside expensive electronics. The market is therefore not one product category. It is a coordinated system in which a cheap fitting can create an expensive outage. Air is convenient, familiar, and easy to distribute, but it carries far less heat than liquid for a given volume. As rack power density rises, fans consume more energy and moving enough air becomes difficult. Liquid can take heat closer to the source and move it efficiently, allowing denser equipment layouts. That does not mean every data center should immerse every server. Lower density halls may remain air-cooled, and many facilities will use hybrid systems. The commercial transition is likely to be uneven. New AI halls first, followed by selected retrofits where power density and energy savings justify the cost. The EDNA report estimates that liquid cooling can cut server energy use by up to 8% by reducing fan power. At the facility level, it can lower cooling-related energy use by roughly 30 to 40%, producing overall data center savings in the order of 10 to 21% depending on deployment and design. Those are system estimates, not guarantees for every site. Climate, supply temperature, heat rejection, workload, and existing equipment all matter. Still, the logic is powerful. Every watt not spent moving heat can support additional compute or reduce the electrical and cooling capacity required for the same output. The fastest growing opportunity may also be the hardest. Existing multi-story data centers were designed around air, floor loading, and pipe routes that may not fit new liquid systems. Retrofitting can require shutdowns, structural checks, new water loops, and coordination across server and facility vendors. The EDNA report highlights high initial cost, limited standardization, long-term reliability concerns, and the need for better retrofit solutions. This creates value for integrators and service companies that can manage interfaces. It also creates risk. A component may be technically excellent but difficult to qualify inside a customer's operating environment. Cooling markets reward compatibility. Buyers need confidence that cold plates, hoses, fluids, manifolds, and control systems can work together across server generations. Standard connectors can reduce lock-in and simplify maintenance, but performance requirements continue to change. Vendors face a strategic choice: own a complete system, specialize in a high-value component, or become the neutral integrator. Watch qualification lists, reference designs, warranty terms, and service coverage, not only product announcements. In infrastructure markets, the winner is often the supplier trusted to keep the whole system operating after installation, not the one with the most dramatic laboratory result. Liquid cooling can deliver heat at temperatures more useful for reuse than conventional air systems. In the right location, that heat may support district heating, industrial processes, or nearby buildings. But reuse is not free. It needs a customer, pipes, heat pumps in some designs, contracts, and matching supply and demand. A data center produces heat continuously. A heating network may need it seasonally. The business case therefore depends on geography and infrastructure. Heat reuse can improve local economics and public acceptance, but only when the thermal output has a real buyer rather than a sustainability label. Ask 5 questions. Where in the thermal chain does the company earn revenue? Is the product designed for direct-to-chip, immersion, rear door systems, or several? How much revenue is equipment, installation, consumables, and recurring service? Which customers have qualified the design, and who owns warranty risk across interfaces? Finally, what happens when chip power and rack density change? A cooling vendor can benefit from AI growth without touching a GPU, but only if it survives rapid standards, procurement cycles, and demanding uptime requirements. Revenue quality matters more than a slide showing total addressable market. The cooling opportunity exists because computation is physical. Every model run moves electrons, and nearly all of that energy becomes heat that must be managed safely. High-density AI turns thermal engineering from a facility detail into a strategic constraint. The value pool spans cold plates, pumps, controls, distribution units, fluids, heat exchangers, construction, maintenance, and heat reuse. But the market will not reward every supplier equally. Standardization, qualification, reliability, and service networks will decide who captures recurring value. To follow the cooling money, do not ask only who makes the equipment. Ask who owns the interface, the warranty, and the relationship after the racks go live.